Hi, so now we are ready to do some blueprints coding for a portal. And before doing so, I want to give you a challenge. So I'm gonna just maximize this, and this is your challenge. What I want you to do is really just add this update cameras function in the BP portal actor. And I want you to connect it to the tick event. So inside of the function, I want you to do partly make some of its implementations, and we will then do the rest together. So inside the function is called update canvas function. Inside of it, I want you to set the relative location of P2 capture to P2 reflections relative location. I want you to do the same thing for P1 capture. I'm having a typo here. And P1 reflection. These are variables in the viewport, and if you look in the viewport and the list of variables to the left, you will find them. We did create these variables and so on for the different portals in the previous lectures. And also, I want you to think of, what's really the purpose of these variables here? P2 capture, P1 capture, and the reflections. What are we really doing? Why are we really doing this, you think? See the viewport and try to understand what's happening when we are running these functions. When I say when we are running these functions, I really mean that when we set the relative location. Why am I setting this relative location? What's happening? And if you look at the variables in the viewport where they are located, you might understand what the point with this is. So try to pause the video now, please, and do this challenge now. Okay, hopefully you finish this. I'm gonna use this as a checklist. So let's see. I'm already having my project here, so let's see what we are gonna. First off, we're gonna create this update cameras function and then add it to the tick event. So let's do that. I'm having my reference project to the right, but we need a new function. So I'm gonna go to functions, add a new function, update cameras. Let's go back to the event graph and connect it to the tick function. I'm gonna double click to go inside of it, and we are gonna set these relative locations. If you go to the viewport before we proceed, you can see that if I just show you the task here again, set the relative location of P2 capture to P2's reflections relative location. Okay, so the P2 capture is, let's see if here is it. That's the capture component. That's the camera capturing data from the scene live, every single frame. We're going to set this relative location to P2's reflection. If you look at the P2 reflection, it's just a scene component. So we're going to set this location to this one here. This means that the P2 capture camera here will actually be located in this location here. So we're just changing its location here. And it really needs to be here. And the reason for that is because, as I mentioned earlier, this is the capture component. It captures, wherever the camera leads to. So if you capture this area in front of the portal, it shows that this is where this portal is really leading, or should I say, the other portal will use this information that is captured by this camera here, because if you remember, if I look at the let's see, P2 capture, if you look here, it's rendering whatever it sees to RTP2, and this is used by the other camera. Only other cameras mesh RTP2. If I go to the other door here, door mesh, let's see, we are using a material here, and this material is really using that. It's using that texture I just showed you. If you look here, is RTP2. If I look at the other door's material here, let's see where the material is. Here, I'm going to show you the material instance. It's actually using that RTP2, as you can see. So positioning these cameras correctly does affect the results of what we will see in the portals. Okay, hope this makes sense. So I want this camera to be moved here to P2 reflection, so it really sees directly in front of the portal, because that's what the other portal will show. The other portal will show whatever this camera will see, which is directly in front of this blue portal, because this is where the blue portal leads when we come out of it. Okay, we go in through the red one and we come out through the blue one. Okay, so it's very important that we place them correctly. I hope this makes sense. So I'm gonna compile and save, and we are gonna do this by code now to move those cameras, and we are doing it relatively to its parent. And by now you should know what relative location is, because we have discussed that. We have world locations and we have relative locations. I'm gonna go to this now, and I'm gonna drag out P2 capture. You can start with this one. Set relative location. It's this one. It's relative to its parent. And I have P2 reflection. I'm gonna get the relative location of this. Let's see, get relative location. That's really it. So let's see, excuse me, let's see the checklist here. So we can also see that we are gonna do the same thing for P1. And yeah, that was really all for this challenge. I'm gonna do that for P1. So let's just drag, where's P1? P1 capture, we have it here. I'm gonna set the relative location. I'm gonna move this up, and then we have P1 reflection. Get relative location. All right, this is just for the first step. Now that these are set, we are gonna do something else. I'm gonna move it here. There isn't really much code here, but we still need to do this mirroring logic here. You will see exactly how it works. I'm gonna hold down the S key and left click, connect this to here. And let's start with the destination one, or should I say P capture one. So I'm gonna get D1. Let's see, yeah. Or maybe I could get D1, but I've disconnected here in my project, so I'm gonna stay consistent here. I'm gonna go with, let's first get P1 capture. We need to get this world location. This is the location in the world. I'm gonna tell you why we are doing this soon. Get world, it's fairly easy actually. Get world location. And then we wanna know where the player camera's location is. We're not gonna get the camera manager, get player camera manager, and get the camera's location. And before we do anything else, I'm gonna show you what P1 capture is. So let's go to the viewport again. P1 capture, we are having it here. If you recall, we are having logic to move it in front of the portal where this reflection vector is. So when we run this at runtime, it will have been moved to this reflection location here. But however, you can think of P1 capture that it captures anything that is in front of the portal here. So what is it really doing? Well, when we capture anything in front of a portal, we are having some logic here. We have the player camera location, and then we are having this P capture location, and during runtime it will be in front of the portal. So what this will do is look at the player really. We want this to look at the player, because if you do that, it will rotate, and when it rotates, it will look like as if the mirroring effect is also moving. It will look more realistic. So if you run to the right, this camera will rotate and look at you when you run to the right, and the mirroring effect will move along with it. So it looks more realistic. Because if you run and change your position, so will the picture, okay? And it looks much more realistic, really. So you will see this in action very soon. So in order to continuously look at the player, we need to implement that logic. So that's what we are going to do now. So that's why I'm having the P1 capture components location, and I'm having the player camera manager here. So what I'm going to do is just do a find look at rotation. So we are going to start at the camera's location here and find the rotation from that location to the camera location. It's find look at rotation. So as you look at find a rotation for an object at a start location to point at a target. So we are finding the rotation from the this P1 capture camera to the player. So it will keep changing constantly depending on the player's rotation. So what are we going to do with that? Well, we first find the rotation we need to look at the player, and then we are going to set the rotation of this P1 capture so it actually looks at the player. But there is one important thing to be aware of when doing this. Let me just duplicate this P1 capture. And I want you to be aware of that. So let's just do this, set world rotation. So now we are telling it to really look at the player. So I'm going to connect this to number 1 here. I'm going to add it up here like this. And really, when we set the world rotation for a child component like P1 capture, if you look here, it says that P1 capture is down here. It's having both relative location, and it is also having a world location. The same goes with rotation. It has a relative rotation. It also has a world rotation. But if you recall from the previous lectures, the world location comes from the root component. That's totally different from the relative location, which is the location relatively to its parent. Okay, we really need to be aware of these differences. Why am I saying this? It's because when we rotate this at in a world scale like this, if you look, this means that in normal cases, those sub-components here, if you look at P1, it's a subcomponent of D1 and the default root scene component. In normal cases, it would be like we rotate the actual actor at a world rotation, but the P1 capture will not really rotate with it. It will keep its rotation. If it's 45 degrees to the right, it will keep its 45 degrees to the right relative to its parent. But there is one thing that is special about this function. If we rotate it at the world rotation, we are really rotating the root component. We are really rotating the root component. However, the special thing with this function is that if you look what it says here, it says put this component at the specified rotation in world space. So we are rotating it at world space, but it also updates relative rotation of the child's. That's the good thing with it. So it will also update this P1 capture component to match that actual rotation. That's the good thing with doing this P1 capture. So if I use P1 capture and rotate it at a world scale like this, it will update the world rotation, but it will also update its relative rotation to its parent. If you don't do it correctly here, you will get the rotations wrong. You might think that, oh, so why couldn't I just, rotate this D1 here instead with a world rotation? No, that will not really work because it will look weird because if you do that world rotation here on this D1, you will notice that those P1 capture, for example, which is the most important one in this case, it will not really update its relative rotation to its parent. We also want it to, update its own rotation relative to its parent, so it matches that rotation. So really, I hope you're understanding this by now. I have already discussed this several times, but I think otherwise you might need to do some testing with world rotation and local rotation and see how the effects are to better understand what's going on. Or maybe you can also refer to that video I showed you earlier before starting this project so you understand the differences between them. So I'm just going to delete this one now, continue with this. So we're setting the world rotation. So basically now P1 capture component, which is the one recording the screen of whatever it sees really to that render target, is just looking at the player right now. So whenever player moves, this will look at the player. And now we're setting world rotation. We are doing some other things here as well in my project here. I think we can wait with that for now at least. What I'm gonna do is do the other one. As a mini challenge, if you want, you can you can pause the video here and do the second one, because currently we are doing the P1 capture that looks at the player. We need to do the same thing for P2 capture, and it's very easy. It's exactly the same basically, but pause the video and give this a try, and then we will take it from there. Okay, hopefully you did that. It's fairly easy. So really, we have two portals. This is the P1 capture for one of the portals, and we need to do the same thing for the other one. I'm just gonna select these, Control D to duplicate. And what I'm gonna do is I'm gonna connect this here and just change the variables really. So P1 capture, I'm gonna go with P2 capture, delete this one. And then we have P2 capture, this is P1 capture. I'm gonna connect it here. All right, P1 capture, P1 capture, P2 capture. I think, yeah, we are having the correct settings here. So now we are really just rotating them and make sure this function is connected to the event graph. You have these update cameras here. I'm just gonna play this and see what happens. And as I mentioned earlier, the portals are only one way, so you can only see them, through one direction. If I go behind, the meshes are in one way, so you cannot really see the portals. But we don't need to worry about that really, because you will spawn in the portals in front of you once we are finished. But if you look at the mirror now, if I move with it, it's really rotating together with me. It's like adapting to my position and looking at me. It keeps looking at me. So it looks like the mirror is like, it really looks like a mirror rather than a magical portal. It looks like this is a mirror, and depending on your angle and direction, it will keep looking at you. And so let's see how it looks like. Yeah, if we go from the very far away like this, you can see how it looks like. So you can see this corner here basically. Let's see if I can. If you go here, you can see this corner from here. It's really hard to illustrate this, but Besides, I don't think the portals need to have collision. So what I'm gonna do is go to, if you open up the portal actor, I'm gonna see what collision settings I'm having in my reference project. We really don't need the portals to collide with anyone. That's really unnecessary. Not, it doesn't, we don't even need that for teleportation. So what I'm gonna do is select the door one. If you go down to the collision settings, it currently says block all dynamic. I'm just gonna change it to no collision. And that was door one. Let's go to door two. I'm gonna change this to no collision. So from now on, we can't really collide with them. Let's just try one more time. So what do you think? It looks pretty good. You can see the weapon here. If I look here, I can see this, round corner over there. And let's just try to, position ourselves on the other side and see, whether we can see things properly. Let's see. It's really hard to, see the correct things from here. Let's see if I can. I can see the other portal from here. Looks a little bit strange somehow. Let's see if I can. I think we will look into this a little bit more in the coming videos. I'm just doing some testing now just to see what I can see and what I can't really see. Because we really need to get things right before testing this out properly with teleportation. And we're almost there. We're not really done yet. Alright. So let's see. I'm gonna quickly take a look at my settings here. Let's see for door one. Alright. Let's see if I can see anything special on the peak capture. I'm just checking my settings so I'm getting things right. Peak capture 1 is using RTP1. Yeah, it looks correct. Yep. Before we wrap up, I'm gonna double check this, the material settings we are using here. If I go to the red one, material instance red one, I'm gonna see RTP2. Yeah, that is correct. And here we got the blue one. It looks like we're having the same settings. I can't really see any big difference really here. I can't really see that we have missed anything. However, we are gonna test this further in the coming lecture. And by the way, let's see if I can. Let's see if we can see anything here. P2 reflection. Let's see the positioning of these. I think these are correct. P1 reflection. Just checking the positioning of those reflection vectors or sinc components. It looks correct to me. All right, so I'm pretty happy with this for now. We are going to continue with this in the coming lectures, so we can very soon start testing the teleportation and everything like that. All right, so thanks for watching, and I see you in the next one.